All right, so when you're thinking about quadratics, you should always think in your mind the different ways of solving them. How do you know something's quadratic? It's when the variable is squared. That means that there are a possibility of two different answers. Normally there are two different answers. Every once in a while, the two answers will be the same roots. So you should be thinking in your mind, there's three ways to solve quadratics. One is by factoring. Set it equal to 0, you factor it, and you figure out the value of each factor. That's one way. We did that last night. Second way is by taking the square root of both sides. This is actually the easiest method to use. As long as you remember a couple things, you'll be in good shape. The third method is called the quadratic equation. That'll come later in the week as we take a look at that third method. Now, if you're going to be able to handle quadratics, you have to memorize that. You got to memorize, okay, how do I solve a quadratic? I'm either going to set it equal to 0 and factor, I'm going to take the square root of both sides, or I'm going to use the quadratic equation. Those need to be your thoughts. Which one do you use? It depends on the problem. Depends on the problem. And so the problem is going to dictate which of the three ways there are. So number one is, remember, there are three ways to solve quadratics. That's got to be foremost in your thought. If you have not memorized those three ways yet, you are already a couple days behind. You need to memorize those, as I said when you guys watched the first lesson. So you got to memorize those three ways. That's the thought that has to be in your head. All right, so when can you use roots to solve quadratics? When can you use roots? You can't always use them. It is, again, as I said, probably the easiest way to solve them, but you can't always use them. All right, so let me refresh your memory on a couple things. This is general form of a quadratic. Normally, the a is a number. For example, I'll stick a 3 there, like maybe 3x squared. Commonly, the b is a number, like plus 7x. And the c would also be a number, and I'll use a minus just because I feel like it, negative 5. And that should have been blue. Come on, blue. What is your problem? Negative 5, and all of that's going to equal 0. Okay, well, there's a middle term, and that's the issue right there. And you can see in the second example, that's the issue right there. There is a variable to the first power term. When that is the case, you cannot take the square root of both sides, with one exception, and that exception we'll talk about a little bit later. Okay. So if there is a variable to the first power involved in the equation, then you're going to try to set it equal to 0 and factor it, like we did last night. If not, then you can take the square root of both sides and solve it by roots. All right, so answer when there is not an x to the first power term. Right? And again, that first power is never shown. There'll be a squared term because it's quadratic. That's what we're doing. So in both of the examples I just gave, you would not be able to solve it by using roots. Okay, you would not, because there is an x to the first power term. When there's not, we can solve using roots. All right, so 3, when taking the square root of both sides, don't forget what? We've been through this. Anybody remember? When I use big, bold red, don't forget to do what? When you take the square root of both sides, what are you supposed to remember to do, Abby? Don't forget the plus minus. Are students going to forget the plus minus? Yes! How? I don't know. I'm warning you. Put an asterisk around it. Put neon lights around it. Make them flash. I don't know. Tie a string around your finger or your neck, whichever will help you to remember. Not your neck, of course. Yeah, you got to remember. You can't forget the plus minus. All right, so thought. How many solutions are there to quadratics, class? 2. Okay. Last night you may have done something that was to the third power. Then you have the possibility of 3 solutions, right? Third power can have 3 solutions. 8th power can have 8 solutions. Squared, second power, have 2 solutions. So guess what? You should catch yourself if you forget the plus minus. You forget the plus minus, how many solutions are you going to have? One. You say to yourself, wait a minute, this is quadratic. There are two solutions. What did I forget? It's the plus minus. You can't forget the plus minus. Some of you will on Wednesday. I'm hoping you won't, but you will. All right. So the methodology we've been through before. It's just the fact that it's quadratic, and that's not a big deal. All right. First thing you want to do is isolate the squared term. We've done this before. We've solved quadratics before, actually. Isolate the squared term. Take the square root of both sides. And one thing I've got to make you aware of, if it's the special case, and I'll show you that in a minute, you got to split it into two equations to solve for both solutions. But honestly, we've done quadratics before. We just didn't say that they were quadratics. So not a lot involved here. Let's get to a couple examples. Come on, move up. All right, so that first example, you look at it, you say, oh, x squared minus 2 equals 42. So let me give you your thoughts, okay? Listen now, pay attention. First thought, oh, it's quadratic. I can solve it by factoring. I could solve it by taking the square root of both sides, or I can solve it by using the quadratic equation. Oh, this doesn't have any x to the first power, does it? See any x to the first power? Oh, good, I can solve it by taking roots, by using roots. That's what I'm going to do. All right, how do you solve by roots? Isolate the squared term. So we're going to add a positive 2 to both sides, right, to move it. I don't even know why I'm showing this step, but just because I want to make sure your notes are clear. So I get x squared equals 44. By the way, when I get to this step, I always try to leave myself a little room after the equal sign. Because what? Now we're ready to take the square root of both sides. Right? Look good? Everybody like what they see? Beautiful. We good? How many think we're good? We good? Did you forget already? You didn't forget already, did you? Man, you got to put the plus minus right then, right there, right then, there. It goes. You got to go right there, right then. Okay. Again, what hurts students in this is after we learn about radicals and stuff, we do stuff like the Pythagorean theorem that's distance, and distances aren't negative, and then all of a sudden you forget to do the plus minus. But this isn't distance, and we got to do the plus minus. Okay, the left side is x. Do I just leave it square root of 44, or do I apply what I've already learned about roots? I apply what I've already learned about roots. So go ahead and simplify it. Simplify the square root of 44. Still going to have the plus minus out in front. Adam, what did you get when you simplified it? Correct. Plus or minus 2 times the square root of 11. So there are the two solutions. Positive 2 times the square root of 11, negative 2 times the square root of 11. Adam simply said, whoa, that a 44 is a 4 times 11, square root of 4 is 2. 2 times the square root of 11. Okay? All right, so go ahead and do B. I'll do it up here while you're doing it down there. Same idea. Oh, it's quadratic. Do I want to solve it by factoring? Do I want to solve it by roots? Or do I want to use a quadratic equation? Oh, there's no x to the first power term. I can solve it by taking roots. Go ahead and set it up to take roots. And please don't forget the plus minus. Don't forget the plus minus. Because quadratics have how many solutions? 2, 2, 2, 2, 2. And every once in a while, just like last night's homework, didn't one of those problems give you the same answer twice. So every once in a while, that's a possibility, but normally not. Look at C. Oh my. Guess what? It's quadratic. I can solve it by factoring. I can solve it by roots, or I can solve it by the quadratic equation. Which of the three do I want to use? There's a first powered term. Bummer. Or is there? Or is there? Right? Hopefully at this point we all know that if you have the same quantity on both sides of the equal sign, you can just cross it off because they add out. Right? If you add a negative 7a to both sides, then the 7a's are gone. So indeed, we can solve this by roots. And again, go ahead. It's got a little bit more junk to it, but it's just junk. Oh no, variables on both sides. I forget how to do that. Again, you solve it at your desk. I'll solve it up here at the same time. If you need to look, because you're not sure what to do next, take a look up and see. If not, see if you can just keep going and solve it. I like to kill a couple birds with one stone. You didn't forget the plus minus, did you? You added a negative 6a squared to both sides. You moved the negative 4 by adding positive 4 to both sides. You moved the 2 by dividing both sides. Took the square root of both sides. Didn't forget the plus minus, right? How many got that correct? And the rest of you know what you did wrong? Simple mistake gets you? All right, don't let those simple mistakes get you. Because you all know how to do that stuff, right? Raquel, question?
When it's 2a squared equals 14,
because the squared term, and take the square root of both sides, what you're asking actually, because right now the squared term is not isolated. There's still a 2 multiplied times it. We haven't isolated it yet, and you got to get it isolated. You got to get it by itself first. Now my a squared is isolated. So I don't take the square root of both sides till it is isolated, right? Everything is moved to the other side. Anything added, anything multiplied. And we know how to move that stuff. All right, go ahead and try D. Oh, it's quadratic. So I want to solve it by factoring, roots, or the quadratic equation. Oh, there's no first power term. I'm going to solve it by roots. Again, if you need help, take a look up. If you don't need help, don't take a look up. Are you done? Did you finish it, I hope? Bottom's easy, right? So right now you're at this point. Plus or minus the square root of 8 over 3. Did you simplify the square root of 8? Always got to look to simplify radicals, right? Kind of out of room, I'll go to the right here. So you should have ended up with plus or minus 2 times the square root of 2 over 3. X equals plus or minus 2 times the square root of 2 over 3. How many got that correct? So again, we're just using things that we know. When you take the square root of a fraction, it's the square root of top divided by the square root of the bottom. You only need the plus minus in one place. You just usually put it in the numerator. If for some reason the 2 and the 3 would have reduced, we would have reduced them. They don't. If the fraction here would have reduced before taking the square root, we would have. It didn't. And again, square root of 8 over square root of 9 is the square root of 8 over 3. The 8 is a 2 times 4. Square root of 4 is 2, and away you go. All right, that's basic nuts and bolts. Raquel, question.
For when to simplify 81, I separate them, like the square root of 8 and the square root of 9.
Not sure what you mean by you separated them. Like this? Is that what you mean? Yeah, and that's the same thing I did. I just did this at the same time and put the 3 on the bottom. So I had the plus minus 8 on the top, square root of 8 on top, and I just went right to the 3. You did one more step, and that's fine. Okay? Not a problem. Any other questions, anybody else? So that's the basic solving, normal kind. Let's deal with the special form. If anything will get you in these, it is the special form, so try to take note of these and pay attention. I don't really think they're extremely hard. The difference here is the quantity has to be isolated. So here's the concept. You don't need to circle this in your notes, but you see the squared term, and then there's a parentheses. Is anything added after the parentheses on the same side as it? No. Is anything out in front multiplied times the parentheses? Not on the original, right? So that's a no. So that means this thing is already isolated, and we're already ready to take the square root of both sides. So it's when the squared quantity is isolated. So I'm going to write it one more time just to be clear in our notes and give myself room to take the square root of both sides. So the squared quantity is isolated. We're ready now to take the square root of both sides. Take the square root of the left, take the square root of the right. So somebody raise your hand and tell me what the left becomes. Ethan? It is x minus 2. Remember, square roots undo squares. And the right is easy. That's plus or minus 2. Don't forget the plus minus. Now, we're not done. This is the special case, and we now have to finish off with the 2 solutions. And the 2 solutions are because of the plus minus. So you're going to make 2 equations. And you have to remember to do this. In one of those equations, you're going to put the plus sign. In the other equation, you're going to use the minus sign. So let me just be clear here. So we end up with x minus 2 equals a plus 2. And I know the plus doesn't need to be there, but I'm trying to emphasize what we're doing. And in the second equation, you have the x minus 2 equaling the minus 2. You see how on one equation I use the plus 2 on the right, and the other equation I use the minus 2 on the right. Now solve those little equations. On the left, you end up with x equal 4, because you add a positive 2 to both sides. On the right, you end up with x equals 0, because you add a positive 2 to both sides. And there are your 2 solutions, x equals 0, x equals 4. So we were able to keep going on this, and we needed to keep going on this. All right, so let's try another one. So you take a look at B, what would you do first? Again, you're looking and you're seeing that there's a quantity squared and no other x to the first power terms. That's the look. I'm going to solve this by roots. So somebody raise your hand. What would be the first move on this one? Alexandra?
Divide both sides by 3.
Yeah, we got to move that 3. So we're going to divide both sides by 3. Now we're at the quantity x plus 5 quantity squared equals 25. So now our squared quantity is isolated, right? You got the squared thing all by itself. Now take the square root of both sides. Of course, don't forget the plus minus. So now we end up with x plus 5 equals plus minus 5. right? X plus 5 equals plus minus 5. Square root of 25 is 5. All right, finish it. Finish it. Finish it. If you need to look up, look up. If you don't need to look up, then don't look up. Quadratic. We were expecting 2 solutions, and we got 2 solutions. How many got that correct? Okay, so you should have gotten 0 and negative 10. You might say, do we always get 0, Mr. Scarfi? Not really, okay? It depends on how complex they are. So let's look at these last 2 here examples. All right, so go ahead and try to do C from beginning to end. Again, if you need help, look up, and I'll try to show you some help, although I am going to skip some steps because this is the end of algebra and we should be quicker in what we're doing. You know what, I better stop you guys on this one because I better show you what to do to finish off. All right, hopefully you're at this point already. You get 3x plus 2 equals plus or minus. What is, somebody tell me what the square root of 20 simplifies into? Adam?
2 times the square root of 5.
Man, Adam's got his roots down. 2 times the square root of 5, right? Plus or minus 2 times the square root of 5. Okay, in this kind of a problem, Alexandra, question? Alexis, question? Why is it plus 2? Because you're not drinking the Kool-Aid and everybody else is. Yeah, because I made a mistake there, right? It's definitely a negative 2, right? 3x minus 2 equals plus or minus 2 times the square root of 5. And hopefully now everybody else agrees, right? All right, here's the situation. In this kind of scenario, we have a radical, we have a square root of 5. We're not going to be able to add a number to a square root of 5. It just doesn't work. And so, because of that, look what happens when we split this up. And I'll split it up. So we're going to do the plus the first time. So 3x minus 2 equals a plus 5. Again, I don't always put the plus 5, but I'm just putting it for emphasis. And when you do, plus 2 times the square root of 5. Almost had you drinking Kool-Aid again. All right, so we got the 3x minus 2 equals positive 2 times the square root of 5 on the second equation. 3x minus 2 equals negative 2 times the square root of 5. All right, we would solve this the normal way. On the left-hand equation, we're going to add a positive 2 to both sides. We like it to go in front of that radical all the time. Commutative property, we could put it in front, we could put it in the back. We like it in the front. So now we have 2 plus 2 times the square root of 5. Everybody okay with that? Right? All I did was add a positive 2 to both sides. How would you finish this? Of course, by dividing both sides by 3, right? And you end up with x equals 2 plus 2 times the square root of 5 divided by 3. That's our preferred format. Now, we would simplify this if it simplified further, if it reduced. It doesn't. The left side, we're going to start the exact same way. We're going to add a positive 2 to both sides. Again, we're going to put that in front of the term with the radical. So instead of saying negative 2 times the square root of 5 plus 2, we're going to do 2 minus 2 times the square root of 5. The plus 2 goes in the front. And again, we're going to divide both sides by 3. and we get our second solution. Do you notice how these two are exactly the same, except one has a plus in the middle of the top and the other has a minus in the middle of the top? Do you see that? So mathematicians love to do things more quickly. And so really what some would do on this, because they recognize that that radical is going to stay there, and whenever there's a radical, they'll just take it in this form. And they'll, let me do it in black so it stands out. They'll add the positive 2 to both sides, put it in the front. They'll leave the plus minus there. And then they'll divide by the 3. And they'll get the answer written together as 1, both answers together as 1. And that's an easier way to do the problem when there's a radical. But please be careful that you remember we're not splitting it up because there's a radical. What do I find as a teacher? I find as a teacher, because students get used to doing the shortcut and not splitting up the quadratic with a radical, that they don't split it up when it doesn't have a radical, and they forget to get the two solutions. So you got to be careful. Any shortcut you use, you got to be careful using it, that you understand it's a shortcut because of something. So again, you could just split it up plus minus. You can get the two answers like this written separately, or because it has a radical and we're not able to add this stuff up, you can leave it with the plus minus. We're going to find, listen now, the third method, right? I've been talking about them all period today. Solve by factoring, solve by roots, solve by the quadratic equation. Guess what the answers are going to look like when you solve by the quadratic equation? They're going to look like that. They're going to be in exactly that format. Because here's the quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That exact format. So again, there's benefit to that. But be careful if you're going to just write it together as one. You can. It's fine. But you got to be thinking, hey, I can do this because of the radical, and it's a shortcut. Just remember to split them up when you can. All right, let's do the last one. Last one. So you're going to move the 1. That's an 18. And I'm going to let you finish it from here. Go ahead and solve it from there. You move the 1. Hopefully you're going to move the 2 and finish it from there. Look up if you need to, but hopefully you won't need to. Finish it off. Didn't get any 0 that time, did you? Because it depends upon the problem, right? Should end up at x equals 1, x equals negative 2 if you did things correctly. Ah, see, we had to split that one up, didn't we? Did anybody leave it plus minus? Okay, so again, you got to be careful. Take them all the way when you can. In that situation, we split it up. Take it all. How many got that last one correct? All right, so let me just add one more note here. Refresh your memory with something. Come on, go up there. All right, so let me refresh your memory on one situation. Don't forget, If the squared term is isolated and the other side is blank, then there is no real solution. Do you guys remember the scenario? When the other side is what? Negative. Now in Algebra 2, we'll deal with non-real solutions. They're called complex numbers or imaginary numbers. But for right now, we don't. So that is possible. You'd say no real solution. All right, that's the lesson. Hope you do well tonight. Alexis.